Imagine something longer than a blue whale, something that floats like a ghost, glows like a lantern, and drags a curtain of death through the freezing seas. That thing exists. And it's not a mythical sea monster, it's a jellyfish. The lion's mane jellyfish, to be exact. You've probably never seen one in real life, and honestly, that might be for the best. Its body is already massive, but its tentacles are something else entirely, stretching up to 37 meters long, which makes it the longest known animal on Earth. Yes, even longer than the largest blue whale ever recorded. From above, it looks like a glowing sunburst drifting gently in the current. But below the surface, it trails thousands of venomous tentacles like a living minefield. And here's where it gets weirder. It doesn't have a brain, or a heart, or even proper eyes. So how does something with no intelligence, no skeleton, and no blood become one of the most effective killers in the ocean? How do its stings work? Could it kill a human? And why does it only seem to thrive in the icy waters of the north? The lion's mane jellyfish isn't just enormous, it's deceptive. It doesn't chase prey, it doesn't ambush, it floats, almost lazily. And anything that drifts too close, fish, crustaceans, even other jellyfish, gets paralyzed in seconds. In this video, we're diving deep into the strangest, coldest, and deadliest corners of marine evolution. We'll explore how a brainless blob became the longest predator alive, how beauty and terror can share the same body, and what this icy assassin can teach us about life in one of the most extreme places on Earth. The lion's mane jellyfish isn't just one of the largest animals on Earth, it's also one of the strangest. Scientifically known as Cyanea capillata, this jellyfish belongs to the class Scyphozoa, the so-called true jellyfish. But even among them, it stands alone as a giant drifting enigma. It's mostly found in the frigid waters of the Arctic and northern Atlantic, especially near Canada, Scandinavia, Russia, and sometimes as far south as the UK. Unlike tropical jellyfish that drift through sunlit lagoons, the lion's mane prefers the cold and the dark. These near-freezing conditions are part of why it grows so enormously. While most jellyfish of this species are already big, with bells about 50 to 60 centimeters across, the largest ever recorded had a bell over 2.3 meters wide. That's wider than a king-size bed flipped on its side. But it's the tentacles that really define it. Arranged in 8 thick clusters, each cluster can contain well over 100 individual tentacles. These fine, hair-like filaments form an almost invisible net that can drag behind the jellyfish for up to 37 meters. If you were swimming in Arctic waters, you could run into one without even seeing it until it was too late. Despite lacking a centralized brain, it isn't mindless. A decentralized nerve net lets it sense light, vibration, and touch. It moves through the water by pulsing its bell in gentle, rhythmic contractions, slow, steady, and ghost-like. And yes, it glows. The lion's mane jellyfish is bioluminescent, producing a soft, eerie light that makes it look almost magical. But beneath that glow is one of the most dangerous drifting organisms in the cold ocean depths. The lion's mane jellyfish doesn't chase its prey, it doesn't stalk, sprint, or ambush. Instead, it turns the entire ocean around it into a drifting trap. Its hunting strategy is simple, brutal, and terrifyingly effective. Float, spread, and wait. Trailing behind its massive bell is a forest of tentacles, sometimes tens of meters long, moving slowly with the current. These tentacles are packed with thousands of microscopic weapons called nematocysts. Each one is a pressurized venom harpoon, coiled like a spring. The moment anything touches the tentacle, those harpoons explode outward, firing venom directly into skin, scales, or shell. There is no warning, no hesitation, just instant injection. Once the venom enters the prey, muscles begin to shut down almost immediately. Small fish freeze in place mid-swim. Crustaceans lose all control of their limbs. Even other jellyfish become helpless, drifting without resistance. The tentacles then slowly contract, drawing the paralyzed victim inward like invisible cables on a winch. There's no struggle. There's no escape. The decision was already made the moment contact happened. At the center of the bell is the jellyfish's mouth, a simple opening that leads into a digestive cavity filled with enzymes. The prey is folded inward and broken down alive. There are no teeth, no jaws, just dissolving tissue. The entire process is quiet, slow, and disturbingly efficient. What makes this hunting style so deadly is how passive it looks. The lion's mane doesn't need to burn energy chasing anything. The ocean itself delivers food straight into its weapons. Currents move the tentacles. Plankton bring in small fish attract larger predators, and everything that wanders into that invisible web pays the same price. Its venom isn't usually lethal to humans, but it is extremely painful. A full-body sting can trigger severe muscle spasms, breathing problems, heart irregularities, and nerve pain that can last for weeks. For smaller animals, though, there is no surviving it. In open water, this jellyfish becomes less of an animal and more of an execution zone. You're not being hunted by something that wants to kill you. You're being filtered out of the ocean by a living net of poison that never even knows you were there. From a distance, the lion's mane jellyfish doesn't look dangerous at all. In fact, it's beautiful. Its bell pulses like a glowing red-orange sun, and its tentacles ripple like silk ribbons suspended in slow motion. It glows faintly with bioluminescence, lighting up the dark Arctic water with a soft, mesmerizing halo. But what looks like a drifting piece of art is actually one of the most efficient killers in the ocean. This is where the lion's mane becomes something far more terrifying, a living contradiction. A creature that stuns with beauty, then stuns with venom. Most predators look threatening. Sharks have teeth, snakes hiss, even wasps send visual warnings. But the lion's mane floats silently. It doesn't have eyes, it doesn't have a face, and yet, its presence alone is enough to wipe out anything that touches it. Its tentacles aren't just long, they're nearly invisible. In the dim, blue-gray waters it calls home, they disappear into the background like threads of smoke. That makes them the perfect trap. Fish swim right into them without ever realizing what hit them. There's no thrashing, no dramatic chase, just paralysis, slow digestion, and silence. This duality, beauty and brutality, is not a coincidence, it's evolution. Its glow may help attract prey or confuse potential predators. In deeper waters where sunlight fades, bioluminescence becomes an important tool, acting like both camouflage and lure. And in the frozen, nutrient-rich Arctic waters, this strategy pays off. It allows the jellyfish to drift confidently through an environment filled with both opportunity and danger. But perhaps the most disturbing thing of all is how unaware it is of what it's doing. The lion's mane jellyfish has no mind, no sense of intent, no understanding of the suffering it causes. It doesn't kill out of instinct or hunger. It kills because that's just how it exists. You could call it nature's most beautiful accident, a creature shaped by cold water, slow currents, and deep time. It's hypnotic to look at, yet horrifying to touch. Like a chandelier made of nerves, light, and venom, floating through the sea with elegance and absolute indifference. So here's the question everyone's thinking. Could the lion's mane jellyfish actually kill a human? The short answer is no, but it's complicated. While its venom is powerful and its tentacles are horrifyingly long, it's not usually deadly to humans. That doesn't mean it's harmless, though. And a full encounter with this jellyfish can result in one of the most painful experiences in the ocean. The tentacles are covered in thousands of nematocysts, tiny venom-injecting cells that can still fire even after the jellyfish is dead. If you swim into a lion's mane, even a detached tentacle can wrap around your skin and unload enough venom to cause intense pain, nausea, and muscle spasms. In severe cases, people have reported difficulty breathing, irregular heartbeats, and even fainting. The larger the jellyfish, the more venom it carries, and the more dangerous the sting becomes. Most stings happen in the North Atlantic during summer, when jellyfish blooms drift closer to popular beaches. Lifeguards in areas like Massachusetts, Nova Scotia, and the UK sometimes have to shut down swimming zones when large ones are spotted. In some extreme cases, people have been stung across huge sections of their body, causing burns, blistering, and nerve pain that can last for weeks. But unlike box jellyfish or irukandji jellyfish, which have been confirmed to kill humans, the lion's mane jellyfish's venom just isn't as potent. It's painful, it's debilitating, but not fatal under normal circumstances. However, indirect dangers are real. Swimmers stung in open water can panic, inhale water, or go into shock leading to drowning. And for people with allergies, the reaction can be much more severe. So while it won't hunt you down or try to attack, an accidental encounter can still end very badly. Think of it this way, it's not trying to kill you, but if you get in its way, it won't even notice, and that might be the most terrifying part. So why did the lion's mane jellyfish get so absurdly large in the first place? You might think it's just a random evolutionary fluke, but there's actually a powerful pattern behind it, something scientists call polar gigantism. In the icy waters of the Arctic and Antarctic, certain species don't just survive, they get massive. And the lion's mane is a textbook example of this effect. Cold water holds far more oxygen than warm water. And for cold-blooded marine animals, like jellyfish, that extra oxygen acts like evolutionary fuel. It allows cells to grow larger, muscles to work more efficiently, and metabolic processes to slow down just enough to favor bulk over speed. Combine that with a slow-paced, energy-conserving lifestyle like drifting, and you have the perfect recipe for scale. In these cold ecosystems, being bigger can actually help you survive longer. Larger jellyfish can hold more nutrients, grow longer tentacles, and passively capture more prey without moving much. And because they don't need to chase anything, there's no penalty for having such a massive, unwieldy body. But that's not the only reason. Arctic waters are some of the most stable environments on Earth. The temperature, light levels, and salinity barely change throughout the year. In this kind of environment, species evolve very slowly but also very specifically. And once a giant form like the lion's mane proves successful, there's no real pressure to shrink back down. Its size becomes its greatest weapon and its greatest shield. Few creatures are willing to mess with a tangled wall of stinging tentacles the size of a city bus, not even other jellyfish. So in a way, the lion's mane jellyfish didn't grow big just to eat more. It grew big because it could. And in the Arctic Ocean, being gigantic isn't a mutation, it's a survival strategy. The lion's mane jellyfish is one of the ocean's greatest contradictions. It's brainless, boneless, and silent, yet it's capable of paralyzing entire schools of fish. It floats like a glowing ghost, draped in beauty, but carries enough venom to ruin your week. It doesn't hunt, it doesn't plan, it just exists, and that alone is enough to make it dangerous. What makes it truly unsettling is how unaware it is of what it's doing. There's no malice, no awareness, and no intention behind the kill, and that might be why it's so haunting. It's not just a predator, it's a passive force of nature, a drifting machine that filters life from the ocean without ever knowing. Its story is a reminder that not all giants roar. Some just float, some don't even know they're deadly, and in the vast, freezing dark of the Arctic, that might be the most effective strategy of all. So the next time you hear that the blue whale is the largest animal on Earth, remember this: there's something longer, and it doesn't need lungs, bones, or brains to dominate its world. Just patience and tentacles. Thanks for watching. If you enjoyed unraveling the mysteries of this drifting monster, hit that like button, subscribe for more creatures from the edge of science, and let us know in the comments what ocean creature we should dive into next.